Welcome to the video using confidence intervals to estimate a population mean with the population standard deviation known. Let's take a look at a sample problem involving that scenario. Here we have a coin laundry. Would like to estimate how many quarters can be expected to come in during a random day of operation. We're told we have a sample here, so let's jot down that sample information. A sample of 49 days of operation has a sample mean of 4,000 quarters. And we're also told that since the shop's opening, the daily quarter intake's standard deviation has been consistent at 700 quarters. Because this refers to the shop's opening, that involves every day that the shop has ever operated, and thus that is a population parameter. Population standard deviation here is 700 quarters. Therefore, the population standard deviation, or sigma, is known. We're working with a sample mean, so we're going to use the x bar sigma known technique. Here we're asked to first make a point estimate of a random day's quarter intake, then to provide a corresponding 94% confidence interval. So let's get started on that. I'll go ahead and jot down our confidence level is 94% here. And first we're asked to come up with the point estimate, and I'm going to go ahead and draw my distribution here. Noting that my sample size is 49, that allows us to assume that this sampling distribution will have the normal characteristic, and therefore use the standard normal distribution to work with it. Alright, and first we're asked for a point estimate, so we're going to jot down 4,000 here. 4,000 is the mean value of the 49 days that were involved in this sample. So at this point, that is the best estimate that we have to represent the whole population. So therefore, that is our point estimate. Okay, also we're asked to provide a corresponding 94% confidence interval. And in order to come up with that confidence interval, we're going to follow two main steps. And recall that any interval is a lower boundary value. Let me jot that down here. So a specific sample mean value to represent the low end of that boundary, and then a symmetrical corresponding sample mean value to represent the upper end of that boundary. And the confidence level, we're told, is 94%. So that tells us that the area in the middle represents exactly 94% of the entire 100% of area under this distribution. Okay, the first of the two main steps is to calculate or find the appropriate margin of error for this interval. So margin of error is a fancy way of saying how many units above or below a midpoint do those lower and upper boundary values fall. So the margin of error is abbreviated with the capital letter E, and our next step is going to be to calculate exactly how many quarters in this case represent the margin of error corresponding to a 94% interval. So let's jot down the formula for the margin of error. In this case, we know the population standard deviation, and we're working with a sample mean estimating a population mean. So we're going to start the margin of error out by finding the appropriate z alpha half value, and we're going to multiply that by the standard error of this distribution. And let's simplify that down a little bit. Z alpha half multiplied by sigma divided by square root of n is what that breaks down to. So our goal now is to come up with these three measures and put them together, and then we'll have our margin of error. So the first one that we need to come up with is z alpha half. And the term z alpha half is related to this being a confidence interval and the fact that it will always be symmetric on both ends of the distribution. So let's first come up with our alpha value. Alpha is the 100% minus the confidence interval size. In this case, our interval is 94%. Therefore, we have an alpha value of 6%. And looking at the name of the variable, z alpha half, next thing we need to do is find the alpha half value. And that's easy enough. It's half of alpha, and what that represents is how much area falls into each one of the two tails in this distribution. So knowing that our alpha half value is 3%, let's see if we can find what z value has an area to its left of exactly 3%. So to do that, we're going to go to our z chart and notice that we're working on the negative side here. That saves us a step. Rather than subtracting 3% from 100% and then looking it up on the positive side, we'll take advantage of the symmetry to avoid that step. So let's see if we can find the closest area in this table to having 3%. So in order to find that, we'll find the area within the table that is the closest area to exactly 3%. So looking down over here, we have an area of 3.01%. That's going to be the closest in our table. So let's look to the left, negative 1.8. Let's look up, negative 0.08. And putting those two together is going to give us an alpha value of, z alpha half value of negative 1.88, and because the z alpha half value is always positive, we'll use the symmetric positive value of positive 1.88. Alright, so that takes care of our z alpha half. So we now know that the margin of error will be equal to 1.88 multiplied by this ratio, the population standard deviation, which we're told is 700, divided by square root of sample size, square root of 49. So in simplifying this, we have 1.88 multiplied by 700 divided by 7. That's equal to 1.88 multiplied by 100, and that's equal to 188. So that now gives us the value for the appropriate margin of error in this case, and it looks like that value is 188 quarters. So that completes the first of the two main steps in calculating that margin of error. So we now know that our margin of error is equal to 188 quarters. So step 2 of the process is to take our sample mean, 4,000, and then add and subtract that margin of error. So 4,000 plus or minus, and that of course would always be positive, plus or minus 188, and we'll go ahead and finish this problem out by saying that the 94% confidence interval is 4,000 minus 188, or 3,812, through 4,000 plus 188, or 4,188. So let's refer back up to our sketch of this distribution, and we'll just go ahead and jot down these numbers here now that we know them. And we can now make the statement that with 94% confidence, the laundromat's expected daily intakes of quarters will fall between 3,812 and 4,188. Thanks for watching.